Welcome to another Extra University video. Today we have a very exciting set of images and volumes to share with you. Since our last video showing the really cool iPhone 16 and 16 Pro CTs or computer tomography, we've been asked by quite a few people, right, Broccoli Rob, what is the difference between 2D and 3D? So we thought, what better way to show you the differences than the brand new Apple Watch 10, and what we did here is a TrueView Prime, so it's a benchtop unit with a CT upgrade. And you can see here on the bottom, we have the 2D image of the Apple Watch. And right here on the top, you have a 3D volume reconstructed from how many images we take with this guy?
We got 3,601 images.
3,600 images. That's really impressive. So here's how it works. 2D images are great, right? You love them. You can see a lot of the device using 2D images. Tony just put out wallpapers. Do you have a wallpaper yet?
Oh, I haven't got mine yet.
You gotta get yours, man. I got mine. So you get the wallpapers and it look really cool. One of the difficulties of the 2D X-ray image is the fact that every single component, especially in a complex device like the Apple Watch, every single component ends up right in one on top of the other. So the image is basically a sum of all these densities onto a flat object, which is the sensor. A 3D representation, because we rotate this device in 0.1 degrees, right? So every 0.1 degrees, we take an image. It allows us to do this three-dimensional reconstruction, which, check this out, you can, with this high resolution, right? This is a couple micron voxel size reconstruction here. As you can see, I can go ahead and rotate and have this beautiful three-dimensional view of the device. So as you can see here, we have the tactile engine, the digital crowns right here, the big speaker, right, that you can play music. You can actually use the speaker to get water, right, out of your watch. So anyway, you can go ahead and rotate and see, you can see the solder balls on the BGAs. I mean, this device is all chip scale packaging, BGAs, and really high density package. You can see the tactile engine here. And we actually went ahead and we created boxes to click those devices to allow you to show them better. So this is the wireless charger. And I can isolate the wireless charger, so all you see is the wireless charger, the connection to the wire, the magnet, and everything else that's in there. This is the little clip that goes on the wristband. So you see, let me show you the whole thing so you can look what we're looking at. Look at the level of detail. The capacitors, the inductors. You can tell a capacitor from a resistor by the fact that a capacitor has a lot of density. So it's radio opaque, so you can actually see the component between the leads. A resistor is virtually invisible to X-rays, and as you lower the power, so you can see right through resistors. But you can see here the little springs that connect to the wristband. That's the big, massive RAM memory on the chip. You can see all the solder balls there. Some really cool stuff on this device. This is I think we took a quick clip of the side. You can see the digital crown, the side button here on the watch. Now, you're telling me something about the new sensors on the watch?
Yeah, I heard that they have depth and temperature sensors for when you're like swimming, snorkeling, whatever. Oh, that's yeah. So when you mentioned that, it has a way to get the water out, I was like, okay, that makes sense that, offering those features, being able to use it in water.
Yeah, that makes sense. So there's a tactile engine. You can see the big magnets here, and the actuator moves back and forth to create the vibration inside the watch. And again, all these features, right? You can see that these features on the 2D image, the X-ray, especially in the Apple Watch, which is several layers one on top of the other, gives you that volumetric representation of the data, so you can slice it, and you can do quality control, you can do reverse engineering, you can do research and development. So there's a huge number of applications for the technology. And the cool thing is we developed this smart CT, which is an upgrade to your current CT machine. So whatever machine you have, and if it's not one of ours, give us a call. Maybe we should give you a CT for less money than you think you would have to pay. Thanks so much for watching, and stay tuned. We have some more new Apple devices, CT, coming up next week. So stay tuned. Subscribe, watch, and if you like it, recommend to your friends. If you don't like it, recommend to your enemies. Thanks for watching.